Good morning to all present here. I am Satish Kumar, working as assistant professor at Department of Electronics and Communication Engineering at K. Sami College of Technology. Today we will discuss about the topic of planar arrays, circular arrays, and phased arrays. First we see about planar arrays. So planar arrays is a two-dimensional arrangements which has multiple antenna elements in a single plane. Often it looks like an electronic rectangular grid used to shape and steer the overall radiation pattern of the antenna system. So planar array are more versatile. So antenna elements arranged over some planar surface. Example, rectangular array. So it provides more symmetrical patterns with lower side lobes. It has much high directivity. It produces a narrow main beam. So applications are tracking radars, remote sensing, and communications. This is a radiation pattern for planar array. This is an example for 6x6 active elements. It produces a radiation pattern steering at particular direction. Next one is circular array. So a circular array antenna is a type of antenna which is multiple radiating elements, which the configuration is look like a circular ring. So offering advantages like azimuth scan capability and pattern invariance, making it suitable for applications like radar, radio, direction finding, and wireless communication. So these arrays are designed with a specific radius and number of elements to control their radiation patterns. This is a figure for a circular array. So there is a circular ring-shaped pattern which provides us a radiation pattern in that areas. So unlike linear array, circular array can provide angular scan both horizontal and vertical. Unlike planar array, circular array are basically one-dimensional linear array, but it is a circular form. So unlike linear arrays, circular array can scan horizontally at 360 degree with no distortion near the entire directions. So where planar arrays are 2D form or circular are one-dimensional form. So next, the last type is the phased array antennas. So phased array antennas is a computer-controlled electronic system of multiple antenna elements that forms single electronic beam steering of radio waves without physical movement. We can control the beams electronically steering the beam using the phase, changing in phase. So by precisely adjusting the phase of the signal or sent or received by individual antenna element, it provides constructive or destructive interference of phase. So directing overall radiation pattern, allowing for rapid, precise beam steering. As the phase either constructive outcome or destructive outcome. So once it produces a constructive phase, it produces a narrow beam steering. This is an example for steering in using the passive electronically steered. So the phase shift is calculated to provide constructive interference. So once it provides a constructive interference, you will get the outcome of beam steering at narrow direction, wherein destructive interference may occur, it cancels each other. So determining a phase shift in accordance with desired directions involving complex mathematical calculations and is done by computer system. The signal from transmitter is sent to the antenna via phase shifter, which is controlled by computer system phase controller. The changing is phase electronically, thus controlling the direction of radiation pattern of antenna array. This is a radiation pattern for phased array antennas, where we can control the beam steering. So advantages are to reduce the overall size. Phased array is best option to use phased array for higher frequency applications. So antenna size is inversely proportional to the frequency. So higher the frequency, smaller the antennas we can use. This makes a phased array antenna a great size for millimeter wave 5G applications. So each antenna element can be controlled usually by phase or time delay, where several antenna elements are equally spaced and divided, and there's a separate phase difference. It is individually separated by phase or time delay. So by changing the feeding, it is possible to construct a directive beam that can be repushed electronically. The amplitude control can be used for pattern switching. So beam can be pointed to new directions or narrowed or widened in microseconds. So we can adjust the beam directions, which is depend upon amplitude and phase control, and antenna that has a main peak at certain angle can also have other peak values depending on spacing between the elements. So we can do the beam steering process by basically adjusting the spacing between the antenna elements, difference or amplitude. We can produce a desired formula. So these are the questions for this session. The students can go through the slides and you can answer the questions. The questions are asked basically from the planar array, circular array, and phased array. Thank you.